All right, so we're going to kind of flip-flop around here, and I have to do this lesson before we can continue, even though it's really a different standard. So you're just getting a very basic introduction to this standard, and we're going to come back to it at the end of the chapter. It's the most appropriate place in the curriculum to teach it, even though it's really kind of a different idea. But we need it to proceed. So you won't be assessed on the entire standard when we get to the first assessment, but it will come back up and you'll see how it connects and how necessary it was for us to put it here. So this is standard 4 video 1, and we'll come back to standard 4 later on in the unit. But our standard is complex number operations. And I'm just going to give you a basic introduction to complex numbers. So you're just getting the intro and we'll come back to it later. So whenever you're ready, go ahead and let's get started. So the first part is, what is a complex number? What is it? Well, it's actually when we take the square root of negative numbers. When we take the square root of a negative number, because up to this point you were told you cannot take the square root of a negative number. And it's not true. It's just that the square root of a negative number is not a real outcome. And by real, I mean it is not part of the real number system. So the premise is that I start with the square root of -1. And the square root of -1 is I. The square root of -1 is I, where I is imaginary. Okay? It's non-real or imaginary. Okay, so if we use imaginary numbers, then we've really just resulted in taking the square root of a negative number. For example, if I take the square root of -5, we can actually separate this and make this the square root of -1 times the square root of 5. Which means the square root of -1 is I, and the square root of 5 is still irrational. So we can say that the square root of -5 is I root 5. What if we take the square root of something else, perhaps the square root of a perfect square, like the square root of -25? Well, that's the same as saying the square root of -1 times the square root of +25. You can separate these because in order to make a radical, we would multiply them back together. So this works. And then this says, well, I have I from that part and I have 25 from this. We always write the I in front of the radical instead of behind because we don't want it to be confused and think that it's underneath of the square root. So it's appropriate to write it in front of there. Now, what if I give you something a little bit more complicated than that? Perhaps the square root of -72. Well, in this case, I'm going to have to break down my square root a little bit more than just by saying I can take out the I, because I still have to simplify the square root of 72. So we can break that down as that I have the square root of -1, I also have the square root of 36, and I have the square root of 2. Now, if 36 isn't the first thing that came to mind, and perhaps you were thinking 9 times 8, well, 9 times 8 will also work. We'll just have a couple extra steps. I'll show you that as well. But this makes I, this makes a 6, and this stays the square root of 2. But the best way to write this answer is 6I times the square root of 2. So let's go back to the square root of 72 and thinking of it as the square root of -1 times the square root of 9 times the square root of 8. Well, I challenge you to think that the square root of 8 is actually 4 times 2. So it's the square root of -1 times the square root of 9 times the square root of 4 times the square root of 2. So this is my I, this is a 3, this is a 2, and this is a square root of 2. And if you were to multiply these first 3 on the outside all together, you would indeed get 6I times the square root of 2. So we've done some reducing here with some imaginary numbers, but it really does simplify to just that I have a square root of a -1 times something else. So if we were to work backwards and I had the square root of -1 times, let's say, of 15, that this is the square root of -15. Now that doesn't make it any simpler. So working the other way, of course, we would have I times the square root of 15. The square root of 15 cannot be simplified because it's made up of two prime numbers, 3 and 5, and neither of those have perfect squares within them because they're prime, so we would leave it as I root 15. So let's just try two more of these where we have to simplify the radical a little bit more. So for example, if I have the square root of negative 28, this means that I have the square root of negative 1 times the square root of 28, which could be written as the square root of negative 1 times the square root of 4 times the square root of 7. Again, if you didn't think of it that way and you thought of it as 2 times 14, you'd end up with a 2 times a 2 times a 7, which is the same as the 4. Okay, again, that'd be 2 times 2 times 7, which is the same as 4 times 7. That's the 14 that you may have thought about. So it's 4 times 7. I wrote 4 times 4. All right, so this leaves me with an I times a 2 times the square root of 7, or 2I times the square root of 7. So at the moment, this is about as much as we have to do with our complex numbers. There's going to be a whole lot more to add to the standard, but as we're starting to solve these quadratics and we're taking square roots, we're going to run into incidences where we have to take the square root of a negative number. So I want you to try these, and I really want you to be careful on these last two, because that's going to kind of lead you towards the quadratic formula, which is coming up relatively soon in our unit. So give these a try and post your answers on Schoology or share them out so that we have something to talk about. And if you've got questions, make sure you ask them.